Suppose
Okay.
there is a
Oh,
EV charging condition as you want to drive some motor from the
okay.
PV panel and your battery also there. Then
Oh,
there is
okay,
a two
okay.
source, PV source and battery also there.
Oh,
For
okay.
analyze that independent sources, then they are using the superposition also to provide the same power to the load. Sometimes,
Three-port converter.
uh,
Okay.
there are the three port. It means a two port for the input side and output side is load.
Oh, okay, okay.
The known as the three port.
So, okay, so Thevenin we are using in power system, right?
Yeah, power system to analyze the power system.
Yeah. What about Norton's theorem, sir? Norton's theorem practically we are using
Same for
current
the
source.
current source and voltage source there. Both are the same.
Yeah, I understood, but practically we are not using Norton's theorem in any power system. Thevenin applicable for Z-bus formation and fault
Yeah,
analysis.
communication lines is there to Thevenin or Thevenin, and Norton is simply to convert the Thevenin to the Norton. It directly you can't use because of there is not current source practically available.
Yeah, yes, sir.
You have to
Mm,
make a
okay.
current source in practical.
Okay, sure.
Yeah.
Thank you, sir.
Okay. Okay. Welcome. Okay. Just wait for some time because the student are connecting. That after that I will start the today's session. Today topic is the two port network. In network system, there are four parameters. Z parameter as like a impedance parameter. Y parameter it means admittance parameter. H parameter it means hybrid parameters. And last one is the transmission parameter, not the ABCD parameter. The two port network is basically two types, pi network and T network, according to the placing of the component. T network means simply placing the component in T shape. This is the T network. Pi network the same, placing the component in pi type. This is the pi network. This is the T network. Okay. Two port network model is in four parameters. Z parameter, Y parameter, then last one ABCD parameter. This one is a transmission parameter. In Z parameter, these classes in
Hello, sir.
impedance parameter. Yes,
Sir, G parameters are ABCD same, sir.
Z parameter and ABCD parameter.
No, sir.
Yeah,
G, and like SAR told like G parameters. So G and ABCD same, sir.
G and Z both are same. It is the impedance. Na impedance mentioned about the like a symbol Z. Na this one is the
No,
Z
sir.
Z parameter.
In,
Yeah,
in lecture videos, SAR has explained Z parameters, Y parameters, H parameters, and the G, sir. GH, like the G parameters.
okay, okay, okay. Then ABCD G parameter like that.
Both are same, sir.
Yes, yes.
Okay, sir. Thank you,
ABCD
sir.
G both are. Is a transmission parameter. Na transmit to line. G is used in the communication line also actually, and ABCD parameter is used in power system. But both are the transmission parameter, so don't confuse them. It is okay. Z parameter is between the this is the impedance model as V1 and V2, and Y parameter is model as the I1 and I2. Is the admittance. Admittance it means I by V, and Z in impedance parameter. Impedance is model as V by I. That's why this one is model as V1 V2. This one is I1 I2. H means hybrid. Hybrid means for both impedance and admittance. That's why this is mentioned in both I1 and V1 and I2. Next one is Z ABCD parameter, a transmission parameter. Transmission is line is transmit from input side. Input side I have a V1 and I1 transmit to output like V2 and I2. This is not like that. Z parameter V1 V2. Admittance is I1 I2. Hybrid it means V1 and I2. ABCD parameters in transmission line transmit the power from one port to another port. It means V1 and I1. This was Z11 I1 plus Z12 I2, Z22 Z21 I1.
Sir,
Yes,
sir, in lecture videos, sir has said V2 I1, sir, not V1 I1.
H parameter
No, sir, ABCD parameters is there, sir.
V1 and
No, sir. Sir has said V1 and I2, sir.
V1 and I2 is the H
Yes, sir.
parameter.
Yes, sir. G parameters, sir has said I1, V1, sir, as resultants. Sir
Sir,
has said like,
Yes,
no, no, no.
wait,
What
wait,
is
wait, wait.
H parameter? You have mentioned V1 I2,
Yes.
ABCD about V2 I1, sir. V2 I1.
No, no. Actually, ABCD parameter is model as V1 and I1 is the transmission parameter. Line transmit from a primary end to secondary side.
Okay, okay.
The V1 and I1. It model as the A V2 plus BI2. is the secondary side, CV2 plus Di2, and this the H parameter is a hybrid. It means mix of both V1 and I2. This is model as IH1 I1 H12 V2 H21 I1 plus 22 and V2. While simply admittance Y11 V1 plus Y12 V2 Y21 V1 plus Y22 and V2.
Sir, then ABCD and G parameters are different, sir, because
I think G parameter is mentioning here. I think in H parameter, I think 8 and G opposite of this one. I think I2 V2.
yes, sir. Yes, sir. Inverse of H parameters is
Yes, yes.
like that, sir.
Inverse of H parameter is G parameter. ABCD is a different. Is a transmission line, transmitter parameter. Yes, yes. Another parameter is G parameter. Which one is inverse of G H? Okay.
So two-port network purely used for communication, sir.
Yes, yes. Mainly it's used in communication, but and communication line mainly use these two parameters G, H, and ABCD in communication line and power system line, transmission line. Transmission line mainly use the ABCD parameter. Because there is use the gain V1 V2 is the gain, I2 I1 is the gain in transmission line. Mainly depends on the gain, finding the gain between them, current gain and voltage gain. That's how you can find directly, and admittance and impedance there. Sorry, nearly three types. The gain is finding, you have to find the gain V1 by V2, voltage gain, current gain I2 by I1, and the impedance is V1 I1 and admittance is I2 V2. If we reverse this one, then order is the G parameter. Simply if you want to find the Z11, simply V1 by I1, I2 will be 0.
So, sir, the
Yeah.
four parameters is common for both network, pi network and T network.
Yes, yes, yes. All can you model like that, pi and T.
Sir, what is pi network and T network?
Yes, yes, sir. Pi and T network is the network which been modeled like that. You can model the transmission line in two way, like in T way or in pi way. That's why this is the pi network and T network. A transmission line, there's a transmission. Actually, if you go in transmission line power system, this one as the model as a capacitor. Both are if you want to take a both end have a capacitor, or you want to combine the both end capacitor in a single line. This is a two-way to representation of the transmission line. That's why this is the network is modeled as a pi network and T network. The positive, if you take a negative this on the ground, then this is the series parameter, resistor, and inductor. You can model this one in two way. Okay, primary side and secondary side, input side and output side, and this is the model as the whole capacitance equivalent in the middle way. Same thing you can model as the two in the capacitor, input side, output side, and transmission line is middle of this one. That's why the network is modeled in two types, pi network and T network. From this you can find the easily all of the parameter. That's why this is the two line is there, the network. Like if you want to find the Z parameter, simply add this one. You can find the Z parameter. For the Y parameter, this one you can use for Y parameter. For the easy calculation, you can model the transmission line like that in pi network or T network. Okay, simply write the how can you find the Z11, Z12 here. For Z11, simply Z11 here, it means V1 by I1, V1 by I1, remaining will be 0, it means I2 is 0. Z12, Z12 is the V1 by I2. In this condition, I1 will be 0. Next one is Z21. Z21 is V2 by I2, I1. Here I2 will be 0. And last one is Z22, V2 I2, when I1 will be 0. Same thing, Y parameter, Y11 is equal to I1 by V1, remaining will be 0, V2 is there, V2 is equal to 0. Next one, Y12, Y12 is equal to I1 divided by V2, when V1 will be 0. Next one, Y21, I2 V1, when V2 will be 0, and Y22, I2 V2, when V1 will be 0. Same can model these two also. H11, V1 by I1, when V2 will be 0. H12, V1 by V2, when I1 will be 0. H21, H21, I2 by I1, current again, when V2 will be 0. H22, I2 V2, when I1 will be 0. Okay, A parameter of ABCD is V1 by V2, when I2 will be 0. B parameter V1 by I2, when V2 will be 0. C parameter I1 by V2, when I2 will be 0. And D parameter, last one is I1 by I2, when V2 will be 0. Actually, transmission line, it will be a negative because of the current direction will be reverse in transmission line. This is the 2 point. The current I2 will be reverse in transmission line. Okay, let's start the question. Then we'll clarify more. Consider circuits on below. Then find the VL, it means output voltage divided by a input voltage. The same, I want to redraw circuit in bigger one. This is a parallel combination of two resistor and another parallel combination of two dependent source. This one RL, VS, this is current is IS, R1, R2 is resistor, this current is I1, this current is I2, and this is current source as beta 1 and I1, this is current source is beta 2 and I2, this current is I mentioned in the question, this is IR, this voltage is VL. Okay, we have to find the VL divided by a VS. Okay, the resistor is given R1 and R2 is equal to 4 ohm. It means this is the 4 ohm, this is the 4 ohm. Okay, and V1 V2 is given as 4. It means this is the 4 I1 and this is the 4 I2. RL is given as 10 ohm. This is the current IS, then this is also same IS. You can apply the KCL at this point, then you can say incoming current, sum up incoming current is equal to the outgoing current. It means IS plus I is equal to IR. We'll get the first equation. IS is the combination of I1 and I2. Okay, and I is a combination of two current, 4 I1 and 4 I2. Then you can put the value here. IS is I1 and I2, I1 plus I2, and I is the combination of 4 I1 plus 4 I2. IR total is the 5 I1 plus 5 I2 is equal to IR. Because here you can see I1 both resistor is same, both resistance is same, then you can say I1 is equal to I2 because of the both voltage drop is will be same, both resistor is same in parallel combination, then you can say I1 is equal to I2. Then if it's the same is it means this is the 10 I1 is equal to IR. Question number 2. Then you can apply loop in bigger one. Then you can say okay, VL in loop started from VS minus of VS plus voltage drop between two is I1 and R1 I1 is a 4 plus this one IR into RL. RL is 10 IR. Then IRL. Where is sweet 10 IR? Okay. And what is the VL? No, VL is the voltage drop on RL. VL you can say as IR into RL. RL is 10, it means VL is equal to 10 IR minus of VS plus 4 I1, and I1 is equal to IR by 10. You can say 4 by 10 IR plus 10 IR is equal to 0. From here you can say IR is equal to VL by 10 minus of VS plus this will be 0.4, 0.4 plus 10 is equal to 10.4 IR. You can say this will be VS equal to 10.4 IR. IR is equal to VL by 10. It means VL by VS is equal to 10 divided by of 10.4. This will be 0.961. Okay. Simply find the current KCL at that point. After that apply the KVL in a bigger loop. Actually you can't apply the KVL here because you don't know about the voltage drop across the current source. Here is directly connected to the RL, then you can say this is also VL. But sometimes if there is any resistor is here, in that case you can't apply the KCL here, KVL here in this loop because I don't know about the voltage drop across the current source. So simply we apply the KVL in bigger loop and put the value according to this, and we'll get the final VL by VS. Okay. Next question is given as a combination of two port network is shown in below, figure below. For the combined network, the admittance parameter Y21 is. In this case, you can see the combination of two port network is, it means they are connected in parallel to each other. Then you can divide this parameter in two parts. In parallel combination, voltage will be same, but current will be different. And to find the admittance parameter, it means Y parameter, you simply add both current in a single equation. In this case, one network is this one. In this one you can say both are the same, connected. And another is this one. This is connected to here. It means this both V1. This both are V1 plus. This both are V1 minus. Okay. Same network I can write in two different way. First one, you can see this one is the pi network. This is the T port network. For pi network, I read it current voltage will be same in both conditions because of connected. They both are connected in parallel. This is given as 4 ohm. This is 4 ohm. This is 4 ohm. Then put this one as I1 dash. This is the I2 dash. Okay.
Sir,
Yes.
sir, I didn't understand that concept. Can you show the top one, sir?
Ex-
Sir, uh,
yes.
like we are doing superposition here, sir,
Yes.
by
Yes.
considering I1 dash, I1 dash, I2, like that we are talking. I1 dash, I1 double dash, like that we are thinking, sir.
Yes. Yes. Sir.
Uh, I mean, sir, superposition for sources we can do, like this resistance also we do, sir.
Because of both are connected in parallel. Like that, suppose there are two resistors. One resistor and another resistor. Suppose this was the V1, this was the I1. Okay. But this is the complication resistor. Then I simply taken as I1 dash, this one taken as the I2 dash. No, sorry, I1 double dash. I1 dash, I2 double dash. Then you can simply add both. I1 dash plus I1 double dash. I simply do like this one. I'm not going to for source combination of superposition. I simply I divide into two part because in the both condition voltage will be same in parallel combination. Both voltage is same but current is different. Then simply I divide into two part this network. Okay, first find this I1, second find this I2 because the admittance parameter is asking know about the admittance parameter combination of I1 and I2. Simply you have to find the current, both current. In the current parallel combination both current will be different but voltage will be same. V1 V2 will be same. In this case, suppose this network, if you try to solve this network is connected like that, and this is the same this one, then this is the one port, one network is this one, plus minus, this is the V1, this is V2. Another is just simply this one is connected to here, it means this one, another is this one is another, this one V1 and V2, both are connected in parallel to each other. These two are the same point. That's why in parallel combination and I simply uh, take the part wise, like first one and second one, both are the parallel, and simply add these two current.
With currents, Y11, Y2, they can also be added, sir.
Yes, yes, yes.
Okay. Now I understood, sir. Thank you, sir.
Okay. Okay. Pi network completed. Second one is the T network. Voltage will be same in both condition. This will be a I11 dash. This will be a I2 dash. I2 double dash. The resistance is 2 ohm. This resistance is 2 ohm. we have to find the parameter. In this case, I1, I2 dash, and this one is the I1, I2. Okay. To find the current, we have to find the KCL. Suppose in this network, you can say what is this current? 4 ohm is directly connected to the V1, then this will be V1 by 4. Same, this 4 is connected to the direct to V2, then this current is V1 by V2 by 4. What this current? This current, this voltage is V1, this voltage is V2. It will directly connected across this one. Then this current will be V1 minus V2 divided by F4. Okay, we have to node, this node and this one, and apply the KCL and we'll get the equation of current. If there is a simple asking only one component, then you can directly find this component by taking the like y21 equal to I2 by V1 if V2 is equal to 0. But for the more understanding, I want to find the all parameter. Sorry. Okay, at node V1, incoming current is I1 dash, then I1 dash is equal to outgoing current is V1 by 4 plus V1 minus V2 by 4. Then this will be I1 dash is equal to V1 by 4, V1 by 4, this will be V1 by 2 minus this will be V2 by 4. Equation number first. At node V2, same current, incoming current is I2 dash is equal to this current V2 by 4 plus this current. This direction will be reversed from this here. Then you can say this will have, you can take a negative one minus this will be V1 minus V2 divided by 4 I2 dash. This is minus of V1 by 4. This is minus plus V2 by 2. Equation number 2. Two current we can find this parameter is I1 dash I2 dash. Okay, for this combination, actually for the pi network it is simple to find the y parameter. You can find easily y parameter by taking two node equation. But in case of T network, it will easy to find the z parameter. Then simply find the z parameter and then you use two equation to find the y parameter after that. Okay, because there is a voltage equation, you have to take a loop. This is the current I1 double dash, this one I2 double dash. Then what is this current? I1 double dash plus I2 double dash. Then after apply a KVL in this loop, first one, second one. in loop 1. What is the V1? Voltage drop across 2 ohm resistor is 2 I1 double dash plus these two resistors is I1 double dash plus I2 double dash. V1 is equal to 4 I1 double dash plus 2 I2 double dash. Equation number for this I taken as a 1 for this parameter. Same thing apply KVL in loop 2 V2. V2 will be I2 double dash into 2 I2 double dash plus same 2 I1 double dash plus I2 double dash. Then V2 will be 2 I1 double dash plus 4 I2 double dash. Okay, but this is the Z parameter. You can take this as easily. You can apply to KVL. You will get the two equation. Two equation is the simply Z parameter. From Z parameter, you have to find the Y parameter. How can you find? Simply, you can take the find the I1, I2 from these two equations. From I1 here, what is the I1 double dash from this equation? V2 minus of 4 I2 divided by of 2. You can same I1 put in this equation 1. And what is the V1? V1 is equal to 4 into V2 minus of 4 I1 to double dash divided by 2 plus of 2 I2 double dash. This is V1 is equal to 2V2 minus of 8 I2 double dash plus of 2 I2 double dash. This is the minus of 6 minus of 6. If you transferring the left hand side, this will be a 6 I2 double dash is equal to minus of V1 plus 2 V2. Then I2 double dash is equal to minus 1 by 6 V1 plus 1 by 3 V2. Equation number 3rd. If we get the I2, then simply put the I2 in equation number 2. Okay, I put this here also. You have to find I1 double dash and put the here. V2 by 2 plus this minus of this will be 2 I2 double dash. V2 by 2 minus of 2. What is the I2 double dash? It will be minus of 1 by 6 V1 plus of 1 by 3 V2. V2 by 2 minus minus of plus 1 by 3 V1 minus 2 by 3 V2. I1 double dash is equal to 1 by 3 V1 plus this will be 3 minus of 4, 3 minus 4, it will be minus of 1 by LCM of these two is 6 V2. This is question number 4. This 2 is the current equation for the second port, second circuit. This one is the 2 equation, these 2 equation is the first circuit. Then for the Y21 we have to find the white I2 by V1 when V2 will be 0. Okay, then take the 2 equation, find the I2 from here. I2 is equal to I2 dash plus I2 double dash. I2 is equal to I2 dash is equal to minus of V1 by 4 plus V2 by 2. I2 double dash is equal to plus 1 by 3 V1 . Sorry, this is the I2. No, this is I2. No? Then minus 1 by 6 V1 plus 1 by 3 V2. Then what is the I2? V1 6 and 4 LCM is 12. This is a 3 minus 3. This will be 2 minus 2. This whole is the minus 3 minus 2 will be 5 V1 plus V2. This will be 2 plus 3. It will be 5 by 6 V2. Okay, for Y21 is equal to I2 by V1 when V2 will be 0. Put the value 0 at place of V2. Then this will be I2 by V1 is equal to minus 5 by 12. It will be minus 0.416. Actually, reverse of the ohm symbol. Okay, because if this is the complicated circuit, then you have to break this circuit. In which way? Then you simply you can add after the finals, after the solving the all equations. This is the parallel combination. In parallel combination, you know the voltage will be same, but current will be different. Then simply find the current parameter for both circuit. Then after simply add to both current to find the final current.
Hello, sir.
Yes, yes.
Can you please again tell like how I1 dash and I1 double dash in this circuit is parallel, sir?
Okay, okay. This is the main circuit, na? I taken as this is the I1 dash and this is the I2 dash. Okay. Now what is the I1? I1 is equal to I1 dash. I1 double dash. I1 is equal to I1 dash and I2 double dash. Same this I2 will be this one I2 dash, this one I2 double dash. And what is the I2? Simply I2 dash plus I2 double dash. This circuit is connected in parallel. This current, and this is the parallel to this current. And this I2 meet at this point and make this T port network. Okay, and voltage will be same because of this voltage, and this voltage will be same, V1 only. Okay, simply I break these two network in two part, I1 dash and I1 double dash. Okay, next one. Two identical Z port network. It means Z parameter Na and Nb are connected in cascade to form a composite network N. The transmission parameter of N is given by this one 5, 4, 4, 5. Then the impedance matrix of individual network. In cascade condition of transmission parameter is simply multiplication of two network. And in parallel combination of transmission parameter is simply add sum of the two network. But it will only possible in transmission parameter, not Z parameter. It means if you take the two port network in transmission parameter is like T1 and T2, both are connected in cascade like that, V1, I1, V2, I2. Then the whole network is just simply multiplication of T1 and T2. Okay, but it is possible in transmission parameter only. Then you can say if I find these two parameter T1 and T2, because the both are same, is say is the identical parameter, two identical Z parameter. If you convert two identical Z parameter, then it will be same identical T network also. Then these two T network is identical. Then you can say T1 and T2 is equal to total network. Total network is given as this one 5, 4, 4 and 5. Then T1 I let this one as ABCD. This one also ABCD 5, 4, 4 and 5. Okay, we multiply this one, then what happened? These two are A square plus BC, and this one is the AB plus BD. This multiplication is CA plus CD, and then this multiplication is D square plus BC. So 5, 4, 4 and 5. Then you get the equation by comparing the element wise. This will be A square plus BC is equal to 5. Then AB plus BD is equal to 4. Then CA plus CD is equal to 4. Then D square plus BC is equal to 5. Suppose this one is one first, second equation, third equation, fourth equation. Suppose I subtract 1 minus of 4. Then what happening? A square plus BC, D square plus BC. BC will be cancelled out. A square minus of D square is equal to 0. it will divide into two parts, a plus d and a minus d. Which one will be 0? We don't know. A plus d is equal to 0 or a minus d is equal to 0. We can't say. Then can you common b here? A plus d is equal to 4. We can common c here. A plus d is equal to 4. Same thing you can see here, a plus d. If you take the a plus d is equal to 0, then it means this one is also 0, but this is not a 0. Then you can say a plus d is not equal to 0. It means the a minus d will be 0. Then a barabar d. Okay. Same thing you can apply here. If a is equal to d, then you can say this will be 2ab is equal to 4, and this will be 2ac is equal to 4 because of a is equal to d. From this you can say, if you divide 2ab divided by 2ac is equal to 1, 2ab divided by 2ac is equal to 1, it means b is equal to c. A will be cancelled out. Okay, but to come the we don't have the value of a, d and b, c. How will get? Suppose a plus b whole square. What is this? Will be a square plus b square plus 2ab. Same thing, a minus b whole square, a square plus b square minus 2ab. In this case, d square is same as a square, a is equal to d, then this you can say this will be a square, b and c is the same, b is equal to c, then you can say this will be b square is equal to 5. Then you can say this will be 5 plus 4 2ab is equal to 4, this will be 9. This will be 5 minus of 2ab is equal to 4, this will be 1. Then you can say a plus b is equal to 3, a minus b is equal to 1. If you sum this one, then we'll get the a is equal to, this will 2a is equal to 4, a is equal to 2. If a is equal to 2, then b is equal to 1. Okay, it means a is equal to 2, b is equal to 1, same as d, same as c. Then you can say the transmission parameter is a, b, c, d is equal to 2, 1, 1, 2.
Sir, how you wrote a plus b equal to 9?
This a plus b is equal to not 9, actually a plus b whole square is equal to 9, because
Yeah.
of a square plus b square I get the here from here. D is same as the a, that's why this will be a square, b is equal to c, then you can put the b also in place of c, then this will be b square, then a square plus b square is equal to 5, and 2ab is here, 2ab is equal to 4. Then I write here a square plus b square plus 2ab. In place of a square plus b square I put the value is 5, in place of 2ab I put the value of 4, then plus 5 plus 4 is equal to 9. 9 is the a plus b whole square, then a plus b is equal to 3. Same thing take as the negative also, then a minus b is equal to 1. If you compare these two,
Yeah, okay, sir.
I will get the value of A and B. But this is not a complete equation. You have to find more also. How can we get this one? You know about the parameter V1 I1 is equal to 2V2. From here you can say this is the ABCD, A V2 plus B I2. This will be 1 simply. Again this is the V2 plus this will be 2 I2. These two are transmission parameter. You have to find the Z parameter from these two. What is the Z parameter? Is the equation of V1 and V2 in play order of Z11 I1 plus Z12 I2 Z21 I1 plus Z22 I2. If in a conversion, if you want to convert any parameter to any parameter, then don't go direct to convert, simply write the equation, two equation, okay, and same these two equation rearrange according these two, then you will get the directly all parameter. Don't go element wise conversion, simply write the equation, these two equation, then same arrange these two equation according to this one, like that. V1 is equal to, okay, you have to I1 I2, you have to replace V2, then from this one we will get the V2 value. What is V2? V2 is I1 minus of 2 I2, okay. Put the value V2 in V1. V1 is equal to V2 2 I2 I1 minus of 4 I2 plus I2. It means V1 is equal to 2 I1 minus of 3 I2. Okay, V1 is completed. Next one, V2. V2 already calculated this one. Rearrange this one. Then you can say, then this Z parameter is equal to I1 is 2 minus 3, this is 1, this is minus 2. Simply rearrange the equation. Don't go for the calculation or conversion of the equation. Simply rearrange the equation, we will get the another parameter. Okay, I think D option is correct. Next, have the box in the figure A contains a linear bilateral passive resistive network. Linear bilateral passive resistive network, it means the V is equal to IR. All are the resistive component. The voltage is increasing, a current is increasing linearly when apply the voltage. All is the resistive network. Okay, and bilateral it means it can current flow from any side. It will not oppose the current direction. The current can flow any side. The passive network, simply resistor is the passive network. The terminal 2 dash are short circuited and a voltage of 20 volt is applied to terminal 1 dash. Then the current I1 and I2 are 10 ampere and minus of 2 ampere. I1 I2 current is given. The box is reconnected as shown in figure B. Find the current I1 dash and voltage across I11. simply this network will be reversed and the voltage applied in reverse direction and resistor is applied in another way, the terminal. It means there is no effect from this one. You can connect anywhere where voltage anywhere resistor, because of this is the bilateral piezoresistant element. So bilateral, it means current flow same in both direction. Same thing if you put the value voltage here and connect the resistor here, then this current flowing, this current is the same as this current. There is no effect in the current flowing of the current. Okay. The short circuited is given. Short circuited, it means can you find directly Norton's current? Norton's current is same as the short circuit current on the terminal. You have to find this resistive network. Then simply this circuit I can rewrite like that. This is 20 volt I1, I2 is incoming like that.
Voice not audible, sir.
Oh, sorry. It means you can reverse the connection, then current will be same. When what is the Norton says? Norton says that this current, if simply if you want to find the Nortons at that across that element, then simply sort this element and find the current like that in this direction. It means you have to find this direction current. This is the IN. Then what is the IN? If I2 is equal to minus up to, then IN is equal to 2.
Sir, is it
Yes.
like reciprocity theorem, sir?
Yeah, same reciprocal theorem. Okay. It means if you when you apply the 20 volt, then current is flowing as 2 ampere. But in the question asking when the voltage apply 10 volt. Same if you voltage apply 10 volt, then current simply half of this one 1 ampere. And this is the Norton's current in this case, which one is asking in the question. Okay. Then after we have to find the resistance equivalent. Resistance, this simply which one you apply the voltage by current, this will be 20 by 10 is equal to 2 ohm. Equivalent resistance any side, you can say any side it will be 2 ohm. Then you can write the Norton's equivalent, a current source parallel with a Norton's resistor. This is 1 ampere, Norton's resistance is 2 ohm. Then now you can connect this resistor of 2 ohm resistor.
Sir, where they mentioned 2 amperes, sir. 20 volt source.
What?
2 ampere.
This one.
You mentioned that 20 volt is 2 ampere.
Yes, yes.
How you?
If you give the 20 volt, then current is flowing 2 ampere. But in the question is given as one voltage applied 10 volt only. If you voltage is half, then same thing current will be also half. Then current will be 1 ampere.
What I'm asking, you mentioned 20 volt is 2 ampere. How you calculated the current 2 ampere? That's not available in the question, right? They given only the option
Okay.
20 volt resistive network.
Yes, yes.
They didn't mention the current value. For
Yeah,
question itself, they mentioned.
yeah.
Sorry.
Mentioning the
Yeah.
question.
Yeah. Okay.
I1 and I2.
Okay.
Okay. This will be a 2 ohm. Then you have to find this IL or I2 dash, any I1 dash is there. Then what is the I1 dash? This simply current divider rules, half of this one, because of both resistance is same. I1 dash is equal to 0.5 ampere. What is the voltage across it? V1 is equal to current into resistor is 2 ohm. This will be 1 volt. Current is 0.5 ampere and voltage is 1 volt. This current is 0.5 ampere and voltage is 1 volt. Okay, this is simply reciprocity theorem. If there is a bilateral linear network is connected in everywhere, then simply if you apply the voltage, then the current is varying directly proportional to the voltage. If you increase the voltage, the current will be increased. If you decrease the voltage, the current will be decreased. Okay. For the next questions, this one is asking about the Z parameter in the circuit. Simply, you can say this is a T4 network, but there is a dependence source also. This is given as I1. Then what is this current? I1 plus I2, because of I2 current is here, I1 is here. Now that's why the middle one is I1 plus I2. Simply apply KVL in this loop. KVL in loop 1. What is the current? V1 is equal to 2 I1 plus 5 plus J3 I1 plus I2. V1 is equal to 2 I1 plus 5 plus J3 I1 plus 5 plus J3 I2. 2 I1 plus 5 I1, real part will be 7 plus J3 I1 plus 5 plus J3 I2. Equation number first. Next one, KVL, applying KVL in loop second. What is this one? V2 is equal to 3 I1 the voltage source. That's why this will be 3 I1 plus 5 plus J3 I1 plus I2. Then what is the V2? 5 plus 3, it will be 8 plus J3 I1 plus I2 is same, 5 plus J3 I2. Okay, this is the Z parameter equation. Question 1 and 2. You can calculate Z parameter right here. Z11 V1 I1, this one 7 plus J3, Z12 5 plus J3, Z21 8 plus J3, Z22 5 plus J3. Okay, simply apply KVL and find the equation. Then after you will get the parameter. I think this is the correct option. Okay. A two-port network is shown in the figure. The parameter H21 for this network can be given by simply this T-port network is asking about the H21. Hybrid parameter is mainly V1 between V1 and I2, mix them, then H11 I1 plus H12 V2, H21 I1, H22 V2. For understanding, simply you have to give the priority of one end voltage in any parameter. Priority is first one. If the first one is a current or voltage, both it will be both or voltage or current, and after that give the priority to the voltage. If the same port is 1 is in same or 2 is there, then first priority is the voltage. Wait, I can explain from this one. Where is this? Yeah, like here from Z parameter, if both are the current, there is not voltage there, then priority is first one I1 and I2. You have to write first I1, then after I2. Okay, in this both cases. Second one is the parameter Y parameter, same, both are same, voltage and both are the voltage, then priority is first one, this means V1. In this case V1 priority, this was the I1 priority, because of both are the same. In Z parameter is current and Y parameter is voltage. Then write the first one is first, like 1 I1 and in this case V1. Next one H parameter. H parameter is in between the I1, V1 and I2. It means hybrid parameter in voltage and current, between voltage and current. Voltage of first port and current of second port. Then remaining is two element I1 and V2. The which one you want to write first? In this case both are different. One is the current, second one is the voltage. In this case give the priority which one is more, like 1. 1 is the I1, then write the I1 current first. V2 is the second port, it means is the second one. Then first write the current, not a voltage. Don't confuse this one. Don't write like V2 then I1. No. Give the priority as a first one, then after voltage priority. If the voltage current is same port, in that case you have to give the priority to the voltage. If the voltage and current is the different port, then give the priority to port is first one. Okay, then I1 is here, V2 is here. In ABCD parameter, both are the same port network, same port element, V2 and I2. Then in this case you have to give the priority to the voltage. First one give the priority to the port 1, after that give the priority to the voltage to write the equations in parameters. Okay, so in the question asking about the H parameter, then H parameter is a hybrid parameter between V1 and I2. Then V1 and I2 remaining is I1 and V2. The first give the priority to the port. First port is I1, I, then after V2. Okay. What is the S21? S21 this one. S21 is equal to I2 divided by I1 when the remaining is 0, then V2 will be 0. Then we have to sort this one. Okay. I write the circuit here. This is V1. This was I1, R, R, R. We have to sort this one. This current is I2, V2. Okay. For the H21, we simply apply the KVL in this loop. What is this current? Simply adding up both current I1 plus I2. Then apply KVL. V2 is equal to 0. Then 0 is equal to R into I2 plus R into I1 plus I2, 0, I2 and I2, R into I2, it means this will be R into I1 plus 2R into I2. Then we have to find I2, then this will be minus of 2R I2 is equal to R into I1, R will be cancelled out, with I2 by I1 is equal to minus of 1 by 2 is the same as H21 parameter. Okay. If any parameter asking like H21, same thing, so you can find directly by writing these two equations. Then find the which one is asking the question like H21. Then take this equation. In this question, if you are asking about the H21, it means I2 by I1, remaining will be 0. Okay. Next question. If the admittance parameter Y11 in the two port network shown in the figure is 2S, then the value of K. In this case, how can you find the value of K? Admittance parameter is given. Or admittance parameter? Simply Y parameter. Y parameter is mentioning the current I1, I2. Okay. Remaining is V1, V2. Then give the priority to the port V1 first, then after V2 second, Y11, Y12, Y21, Y22. Y11 is given. Y11 is I1 divided by V1 when V2 is equal to 0. V2 0, it means this will be short circuit, voltage will be short circuit, current is open circuit. This is the short circuit, this current is I1, this current is I2, then what is this current? I1 plus I2. If this current is I1 plus I2, then you can say Ix is equal to minus of I1 plus I2, because of I1 plus I2 is flowing in negative direction. What is the V1? V1 simply connected across to 2 ohm resistor. V1 is equal to 2. Actually, current will be reversed in Ix. If you see Ix is the opposite direction. Then V1 is equal to minus of 2 Ix. and ix is minus of 2 I1 plus I2, then this will be a 2 I1 plus I2. Question number first. Then apply KVL in loop 2. What is the V2? V2 is equal to 4I2 plus K into Ix. What is Ix? Ix is negative of I1 plus I2. But this is the negative, then this will also a negative. Then plus 2 I1 plus I2. 4I2 minus of K minus 1, this will be plus K I1 plus K I2 plus 2 I1 plus 2 I2. Then V2 is equal to 4 plus 2 6 plus K. Oh, this will negative, negative will be positive. I1 plus 2 plus K I1. Then we have to find the relation between I1 and V1. Then V2 will be 0. Then this will be equal to 0. Then you can say from here what is the I2? 6 plus K minus of 6 plus K I2 is equal to 2 plus K I1. Then what is the I2? I2 is equal to negative of 2 plus K divided by of 6 plus K. Same thing, you can put the value of I2 in equation 1. In this case, V1 is equal to 2I2, 2I1 plus 2I2. I2 is equal to negative of 2 plus K I1 divided by of 6 plus K. This will be, if you take the common of 2I1, then this will be 1 minus of 2 plus K divided by of K plus 6. This will be V1 by I1 is equal to 2. LCM of this one is equal to K plus 6. This will be K plus 6 minus of 2 minus of K is equal to 2. K will be cancelled out. This will be 4 by K plus 6. And this value is y11, and this is given as 2 in the question. 2s. Y11 is 2s. Then 2 will be cancelled out. Sorry, this was a V1 by I1, but in the question I1 by V1 is 2. This will be 2. Then V1 by I1 is equal to 1 by 2, not 2. I taken the question 1 by I11, not V1 by I1 is equal to 1 by I11. That means 1 by 2. Then this will be a 16 is equal to K plus 6. Then K is equal to 10. 16 minus of 6 is equal to 10. Okay. Actually y11 is equal to I1 by V1 when V2 is equal to 0. And this is the given in the question as 2.
Sir, that is mentioned 2 Siemens, right? Unit.
Yes.
Okay.
Actually 1 by 2 is the ohm. If you reverse this one,
Yes, sir.
this is the ohm and it means resistors are impedance. If you reverse of this one, Z is equal to 1 by Y. Then if this is the ohm, then Y is in Siemens, opposite of ohm. Next is the given for the circuit shown the hybrid parameter matrix is. So asking about the hybrid parameter. Hybrid parameter it means H parameter. H parameter between IV1 and I2. Remaining is I1 and V2. The priority is port in this case. Port is I1 first port, then second port. H11, H12, H21, H22. Okay. Simply write the circuit. Okay. V2, this one we have I2 is given. This is a 2 ohm. This is a 4 ohm. I2. This is V2, V1, and this current is I1. Okay. You have to find the equation. Two equation, V1 and I2 in terms of I1 and V2. Here is current is given as I1. This current is I1 and this current is I2 by 2. Then what is this current? It means I1 minus of I2 by 2. This is same current is here. This current is I2. This current is I1 minus of I2 by 2. Then what is this current? Both current is coming and going to 4 ohm resistance. Then I1 minus of I2 by 2 plus I2. Then this will be I1 plus I2 by 2. You can say this resistor is directly connected to the across to V2. Then what is the V2? Conductor says that this 4 ohm resistor and current. What is the current? Current is I1 plus I2 by 2. It means this is the 4I1 plus 2I2. We have to find the current of I2. Na? I2 in terms of I1 and V2. Only 3 parameters there. Then we get the value of I2 from here. I2 is equal to minus of 4. 2 by 2 is equal to minus of 4 I1 plus V2. Then what is the I2? I2 is minus of 2 I1 plus half V2. Equation number first. Then you can't apply the KVL here in this loop. Why? Because I don't know about the voltage drop across the current source. Then you can't apply KVL. Then what happened? Okay, further you can simply apply KVL in this loop. KVL in loop 1 started from V1 is equal to all of the V1 is equal to first, this is given as a V2, then plus V2, then plus 2 into this current plus 4 into this current. Okay, V1 V2 plus 2 into that current I1 minus of I2 by 2 and plus 4 of this current I1 plus of I2 by 2. V1 is equal to V2 plus 2I1 minus of I2 plus 4I1 plus 2I2. V1 is equal to V2 plus 6I1 plus of I2. We have to replace the current V2 in terms of I1 and V2. This will be V2 plus 6I1 plus I2. I2 from this equation 1, I2 is equal to minus of 2 I1 plus half of V2. V1 is equal to half V2 plus V2 is equal to 3 by 2 V2 plus I1 6 I1 minus of 2 I1 is equal to 4 I1. And what is the V1? The term of port I1 plus 3 by 2 V2. Equation number second. V1 and I2. I2 is given in the upper side, minus of 2 I1 plus half of V2. And what is the H parameter? This will be first 4, then 3 by 2, then minus of 2, then 1 by 2. Okay. Simply find the equation according to the given parameter equation and put the value of all element according to this. Okay. Next question is given as the consider the following network. The transmission parameter D and hybrid parameter H12 are respectively. We have to find two parameter. First one T parameter, transmission parameter. Equation is V1 and I1 is equal to A V2 plus B I2, C V2 plus D I2, Next one is H parameter. H parameter hybrid I1 and V1 and I2. H11 I1 plus H12 V2, H21 I1, H22 V2. Then you have to find D parameter and H parameter. For D parameter, D is equal to I1 by I2 when V2 is 0, and H21 parameter, H21, sorry, H12 I think, H12 is H12 is here. This V1 by V2 when I1 is equal to 0. Okay. First of all, write the equation first from for the D parameter. For D parameter, V2 is equal to 0. V2 is equal to 0, it means this will be short circuited. If this is the short circuit, then this resistance have no meaning. This network is only this one. Okay. Go to the short circuit here. V2. V2 will be 0. This is circuit, this is no meaning, this is I2. Then you can simply remove the circuit. Sorry, there is another resistance also. This resistance is 1 ohm. In this case, what is the current flowing through this branch is I1 plus I2. Then you can say V1 is equal to 2 I1 plus I2. Okay, same you can apply KVL in this loop. V2 will be 0. This will be 4 I2 plus 2 I1 plus I2 plus this 1 is I2, and this will be 4 I2 plus 2 I2 plus I2 is equal to 7 I2 plus 2 I1. Then no need actually this one equations also. This D parameter is D is equal to I1 by I2 is equal to I1 by I2 is minus of 7 by 2. Okay. Actually in transmission line, the current direction will be reverse in all parameter. This will be I2. That's why you have to put the negative value here. Then this will be a positive 7 by 2. Actually in transmission line only, this is the current will be reverse. In all parameter, current direction will be here like that, but in the transmission parameter, current direction will be reverse. Then we have to put the minus of I2 in place of I2. Okay. The H parameter, or the H parameter, what is the current? For the H parameter, I1 will be 0. And I write the circuit again for H parameter. This is I1, this is I2, 4 ohm, 2 ohm. So our resistance is here, 1 ohm. I1 is equal to 0. This current is 0. It means there is no current. It means same current is passing through like that. Okay, I2 only. Then you can use the current divider. Then all three are connected in series. If this current is not matter 0, then what is the current? Flowing through a 2 ohm resistor. I2 divided into two part, because of this is the all three are connected in series. Then what is this current? Current into opposite resistance 4, 2, 6 plus 1, 7 divided by total resistance is 7 plus 2, 9. In this case, I2 into current into opposite resistance is 2 divided by total resistance is 9. Then you have to find the V1 and V2. In this case, what is the V1? V1 current flowing through it into resistance. V1 is equal to 2 ohm resistor, and what is the current? 2 I2 by 9. This is the V1 is equal to 4 by 9 I2. And same, what is the V2? V2 2 ohm resistors and 7 I2 by 9 current. What is the V2? V2 is equal to 14 by 9 I2. Sorry. For the parameter H21, H12, V1 by V2. Simply you can divide these two equations, V1 by V2, it will be a 4 by 9 divided by a 14 by 9. I2 will be cancelled out, 9 will be cancelled out, 4 by 14 is equal to 2 by 7. Okay. The another question is, consider the
Hello, sir.
circuit. Yes, yes.
Sir, can you send your mail ID, sir, like for asking some doubts maybe, or you told last time like question paper, if you have, you can send to us, share to us
Yes, yes.
previous year questions. So can you type and give me in chat? Okay, thank you.
Shiv Prakash
Okay, sir.
dot rs dot triple e 21 at the rate of itbhu dot ac dot in.
Okay. Thank you, sir.
Yes, welcome. Actually, this question is another question that type. I want to solve this question in next class, please, if you don't mind. I want to stop the question, today's session here, and I solve this question in next session. These are 2 to 3 question, same type, this type.
Okay, sir. Thank you.
Yeah, I will solve in next session. This one, all of the three
Sir,
part.
actually, I
Thank you, sir.
feel that question,
Yes, sir.
number of questions are more, sir, for each assignment.
Yes, and I think the 2 to 3 question is there for same time, same type. Okay, that's why I want to solve
No, no, no,
all
no,
question
no, no.
together. Huh?
No, sir. Generally, I'm telling
Uh,
for week 1 to up to week 7, right?
yes, yes.
For I think it's more number of questions, sir. It will be very difficult. That's only we are losing the marks also.
Okay, okay, okay. How many questions is asking? I think.
Actually, usually 10, sir, only 10. But here, more number of subdivisions, more
Okay.
number of questions are there.
Yes, yes. Okay, don't worry. Simply follow the all of thing. Listen, you will get the answer of all the question.
So you just convey the information. So this is our feedback.
Actually, all this assignments problem I'm not set. That's why I've not set the assignments problem. That's why I can't say anything about that.
Okay,
So
okay,
one,
sir.
so one more thing I was thinking, sir, like, sir, you are kind of expert to these questions, and doing 10 or 12 questions, it will take around 2 hours or something. Like, sir, in exam, it will be some 40, 50 questions. So how to manage so many questions in 3 hours? I
Yes,
don't know.
yes, yes. But you have to practice all the question for finding the shortcut. Shortcut it means can't say, but you can skip some lines if on your
Sir,
mind.
Okay, sir.
one more difficulty during the examination, right? It's online.
Hmm?
We are using only online calculator, right? And online calculator, converting that
Ah,
rectangular to polar, polar to rectangular is also it's very difficult.
yeah, they will be difficult to solve.
Yeah, it will take more time.
Yes,
For
yes, yes.
probabilistic subjects, it's not possible to use online calculator, sir.
Yes,
So
yes.
that only we are losing many more questions also.
You have to practice more and more. All
Sir,
that.
that's not the solution, sir.
Uh, or
We are not the
simply,
aliens.
this is a simply rectangular form is the main. A cos theta plus j sin theta is taken the long one to
Yeah,
add
it's
two
take
thing.
more time,
Yes, yes,
for
I understand.
finding.
At the online
So,
calculator, if you want to use that calculator, then please solve the all of thing, all equation, uh, taking the all of the variable one only. At the last, you have to take the calculator. Don't use the
okay,
all calculation and middle one directly. First one, start the equation and solve that problem by taking the variable only, not to put in the all value. If you put the all value, then you need the calculator at every point, every stage. Then simply follow the all the equations, solve the all equation by taking the variable only x, y, z. Don't put the value of this one or some this like in this case register is there or some impedance is there. Then follow this one only. Don't put the value of resistance and impedance. And the last one, if you have a last equation there, then after the at the end of the equation you put the directly all the values and find the answer. Then in that case you have to use the less amount, less time, take the less time because of you use the some calculator, some time calculator only for some calculation only, not for the all calculation. Then you can save the time.
okay, sir.
Yes, sir.
Okay.
But
Thank you, sir.
if you put the value of every point, point there, then you have to uh, take the calculator and use the calculator at every stage. Then it will be take the time.
Yes, sir.
Yeah. But polar form have taken the time. I understand.
Yes, sir.
Yeah.
Thank you, sir.
Okay.
Thank you, sir.
Okay.
Thank you.
Thank you. Close.